I'm Dr. R.J.Golden Renjith Nimal, Associate Professor, Department of Mechanical Engineering, Bharat Institute of Higher Education and Research, Chennai. I'm going to discuss about the topic gears and gear trains in theory of machines. What is the gears? So gears are toothed wheel used for transmitting motion and power from one shaft to another when they are not too far apart and when constant velocity ratio is decided. So if the distance is too large, then we can go for some other transmission devices. There are so many transmission devices out there. Belt drive is there, chain drive is there, friction drives are there. So we can go some other alternative. These gear drives are more compact and can operate in high speeds and can be used where precise timing is required. Also, gear drives are used when large power is to be transmitted. The force required to hold the gears in position is much less than in an equivalent friction drive. So this results in the lower bearing pressure, less wear on the bearing surfaces. So mostly this is always produce a change in torque, creating a mechanical advantage through their gear ratio. So it's we can use it in so many places. Even though nowadays cycle also we are using the gears. What are the advantages of gear drive? So since there is no slip, so exact velocity ratio can be obtained. Then we can have, it is very much capable of transmitting large power than that of the belt and chain drives. It is more efficient and effective means of power transmission. So it's there are different types of gears we can see in the next slides, and it requires very less space. So if we are using a belt drive, it takes very large space, but it needs very less space when compared to the other drives like belt, ropes, chains, etc. Then there is some limitations are there. So limitations of the gear drives or the manufacturing of gears requires special tools and equipments. We can cast, we can manufacture in so many ways. Right? And this manufacturing cost is somewhat high comparatively, and the errors in the cutting teeth may cause vibrations and noise during the operation. So what is make gears actually? So gear is a circular body of a cylindrical shape or that of the shape of frustrum of cone and of uniform small width having teeth. A number of teeth are there, uniform formation provided on its outer circumferential surface. So it is called as a gear. We can call it as toothed gear or toothed wheel. So if the gear is two mating gears are there, so the largest gear is the wheel or gear, and the smallest wheel gear is called as a pinion. We can call it as pinion. Then these gears are either cast or teeth are cutted on a circular plate called as gear blank. Gear blank. Then come to the classification of gears. So we can classify these gears in so many ways. Initially we can classify based on the relative position on their shaft surfaces. So first one is it is classified into three types. One is parallel shaft. Second one is the intersecting shafts. Third one is the non-parallel, non-intersecting shafts. So the first classification has some examples. So many examples are there. So first parallel shaft means per gear, then helical gear, then herringbone gear, right? Rack and pinion, then all type of internal gears. So these are all the examples for the parallel shafts. Then second one is the intersecting shafts. Intersecting shafts means example is bevel gear and spiral gears. Then come for the non-parallel, non-intersecting shaft. So that is a worm and worm gear and hypoid gears, etc. So these are all the classification based on the relative position on the shaft axis. So we can, I'll explain you what is in by spur, what is in by helical, what is in by herringbone, and so on, right? So before that, we can have some more classifications are there. So classification based on the relative motion of the shaft. So it is classified into two types. One is the row gears and planetary gears and differential gears, right? So differential, we are using some gears. So this is a gears we have put there. And third one is the classification based on the peripheral speed. So low velocity gears, medium velocity gears, and high velocity gears. So what is it by low velocity gears? So the velocity is below 3 meter per second, means then it is called as a low velocity gears. Medium means 3 to 15 meter per second, means then it is called as in medium velocity gears. And the last one is a high velocity gears. High velocity gears means above 15 meter per second, means then it is called as an high velocity gears. Then come to the classification based on the position of teeth. So teeth on the wheel, it is of four types. One is the straight gears, helical gears, herringbone gears, and curved teeth gears, right? So, and the last classification based on the type of gearing. So internal gearing, external gearing, and rack and pinion. Come to the spur gear. What is it by spur gear? What is it by spur gear? So spur gear, in the sense, what is the teeth are straight and parallel to the axis of the wheels, to the axis of the wheels. So that is called as an a spur gear, and they are very much used to transmit the rotary motion between the parallel shafts. And this gearing may be internal and external. So external gears rotate in opposite direction, while internal gears rotate in the same direction. So that is the difference between the internal and the external. So spur gear is all teeth are always straight and parallel to the axis of rotation. So example, we can see electric screwdriver, oscillating sprinkler, wind up alarm clock, then washing machine, then clothes dryer, right? So this is I showed some examples in the screen. I mean photos of the gears. So this is a gear, spur gear. So external gear, what is in the external gear? This is an external gear. So external gear, I already explained you. So external gear is the gears of two shafts mesh externally with each other, which is shown in the image, I mean diagram. And the larger of the wheels is called spur wheels, and the smallest one is called as a pinion. I already mentioned you. Then similarly for internal spur gear. So internal spur gear means the teeth are internally arranged. So the larger of these two wheels are called annular wheel, and the smallest wheel automatically it is called as a pinion. So this is called as an spur gears. Then come for the helical gear. So helical gears means simple modification of ordinary spur gear. The use of the spur gear is most common when two parallel shafts are connected. However, to reduce noise and to improve the smoothness of the operation, helical gears are preferred, right? And the helical gears has teeth in the form of helix around the gears. So the image is already I mentioned in the slide, and a pair of helical gear is seen that the teeth of the two wheels are in the opposite hands. So the helix are at right angles right-handed on one wheels and left hand on the other. So these are all the important things of the helical gears. Normally it is a right angle, so 90-degree. It is adjusting, right? And so there are some terms which we are using for helical gear. Helix angle, spiral angle, then lead, then normal pitch, then axial pitch. The axial pitch is otherwise called a circular pitch, right? We can see elaborately while we are studying the terminologies of gear, right? So helix angle is the angle between the tooth axis and plane containing the wheel axis. So this is called as an helical gears. Come to the herringbone gears. What is it by herringbone gears? What is it by herringbone gear? Herringbone gear is a specific type of double helical gears, and which is side to side. So one of the disadvantage of the single helical gear is the existence of axial thrust load. So they are eliminated by the herringbone configuration. So because the thrust force of the right hand is balanced by that of the left hand helix. So helix angle, here also we are having a helix angle. You know what is in the helix angle. So helix angles are usually greater for herringbone gears than for single helical gears because of the absence of thrust reactions. So this herringbone gears are preferred. Then come for the rack and pinion. What is in the rack and pinion? So there is a rack and pinion is there. So a rack is normally a straight line gear measures with a circular wheel. So it is called as a pinion. We know that the combination so far formed is called the rack and pinion arrangement. So rack can also be defined as the gear wheel of infinite radius. So with the help of this arrangement, rotary motions can be converted into linear motion and vice versa, right? So the perfect example for this is steering system on many cars. We can use this rack and pinion steering gearboxes there. So so many examples we can say, right? So and not only that, the use of rack may be found in the lathe, where the rack gives motion to the saddle. So come to the bevel gears. What is it by bevel gears? So bevel gears are used for connecting two shafts whose axes are intersecting. So the pitch surface in the bevel gears are like a cone, and one of which rolls over the other. So when the teeth formed on the cones are straight, and the gears are known as straight bevel, and when inclined they are known as spiral or helical bevel. So this is called as a bevel gear. So the application is very wide for bevel gears in marine application, then automobiles, then printing presses, then power plants, then steel plants, etc. So this is called as an bevel gears. Then come for the straight and the spiral bevel gear. Straight and parallel bevel. What is it by straight bevel, and what is it by spiral bevel, right? So straight bevel means if the teeth on the bevel gears are parallel to the lines generating the pitch cones, then they are called straight bevel gears, right? So normally the teeth are straight, radial to the point of intersection of the shaft axis, and vary in cross section throughout their length. So usually they are used to connect the shafts at right angles which run at low speed. So this is called as a straight bevel gears. And come for the spiral bevel. What is the spiral bevel? So already we studied about the spiral. So when the teeth of a bevel gears are inclined at an angle to the face of the bevel, so they are known as spiral bevel gears. To reduce the noise, helical teeth is used on these bevel gears. So they are smoother in action and quieter than straight bevel gears. And however, an axial thrust exists in the spiral bevel gears, so it requires bevel stronger. It requires stronger bearing and supporting assemblies. So the in differential automobile is a very best example for this spiral bevel, right? And come to the warm and warm. What is the warm and warm gears, right? Warm and warm means this type of gearing is generally used to transmit power at high velocity ratios in one stage between two non-intersection shafts. So the angle between the non-intersecting shafts is usually, but not necessarily at right angles. So the gears have surface contact, and thus they are able to transmit more power. The sliding velocity of the warm gears is higher as compared to the other type of gears. So warm with one thread is called single threaded warm, and warm having two, three, or four anything is called as a double, triple, and quadruple, and vice versa. We can say like that, right? And they are used for high speed ratios up to 500:1, right? And the spiral angle of warm thread for maximum efficiency is slightly more than 45 degrees. So this is the thing. So mainly it is used in material handling, transportation, machinery, then machine tools, then automobiles, etc. So generally gears are mainly used in automobiles. So this is called as a warm and warm gear, right? It is called as a warm and warm gear. So this is the velocity ratio which we are used here. And come for the gear terminologies of gears. So what are the important nomenclature, right? Nomenclature of the gears. I'll explain each and every part, right? So first one is the pitch circle. Before studying the pitch circle, we should know what is the pinion. Already I explained you. So the pinion is the smallest of two mating gears. The larger is often called the gear or the wheel, right? And what is the pitch circle? Pitch circle is the imaginary circle which have pure rolling action, would have the same motion as the actual gear, right? And what is the pitch circle diameter? Pitch circle diameter is the diameter of the pitch circle. The size of the gear is usually specified by the pitch circle diameter, and it is also called as pitch diameter. Then what is the big pitch point? Pitch point. So pitch point is a common point of contact between two pitch circles. Then what is the base circle? Base circle means it is a section from which the involute section of the tooth is generated. So the pitch point, what is the pitch point? I already explained you. Then pitch, what is the pitch? Pitch means pitch is the two mating gears must be the same one. So consecutive gears, consecutive teeth, right? And come for the addendum and dedendum. What is the addendum and what is the dedendum, right? The addendum circle is addendum is the radial distance of a tooth from the pitch circle to the top of the tooth. So and what is the dedendum? Dedendum is the radial distance of the of a tooth from the pitch circle to the bottom of the tooth. So that is the that is called as an addendum and dedendum. So addendum, so what is the addendum circle? Addendum circle is otherwise called a tip circle, and it is a circle drawn through the top of the teeth and is concentric with the pitch circle. And what is dedendum circle? Dedendum circle is otherwise called as root circle, and it is the circle drawn through the bottom of the circle. So this is called as an addendum, addendum circle, and dedendum circle. Then what is meant by circular pitch? Circular pitch means it is a distance measured on the circumference of the pitch circle from a point on of tooth. It is usually denoted by PC. Then come for the clearance. What is the clearance is very important, and it is the radial distance of the from the top of the tooth to the bottom of the tooth in a meshing gear. So a circle passing through the top of the meshing gear is known as the clearance circle. Then tooth thickness. Tooth thickness means it is the width of the tooth measured along the pitch circle, right? And tooth depth means total depth. Total depth means that is it is a radial distance between the addendum and the dedendum of the teeth. So then the diametral pitch. Diametral pitch is the ratio of the number of teeth to the pitch circle diameter. So normally we can measure in millimeters, and it is denoted by PD. So PD means that is a diametral pitch. Then what is the backlash? Backlash. Backlash means it is a difference between the tooth space and the tooth thickness along the pitch circle. So it is called as an backlash. And these are all the important terms for the terminologies. Then what is the module? Module is the ratio of the pitch circle diameter to the number of teeth. So this is called as a module. It is normally mentioned by m, right? Small m, and small m is equal to d by t. Then clearance already we studied. Total depth we studied. So working depth. So working depth, it is the radial distance from the dedendum circle to the clearance circle. So it is equal to the sum of the addendum of the two meshing gears. So this is tooth space. Tooth space means it is the width of the tooth measured along the pitch circle, right? And tooth thickness. What is the tooth thickness? Tooth thickness is it is the width of the space between the two adjacent teeth measured along the pitch circle. Backlash already we studied. So face of the tooth. So face of the tooth means it is the surface of the tooth above the pitch surface. Then topland. Topland means surface of the top of the tooth. Then flank. Then face width. So these are all the terminologies of the gears. Per gear normally, right? This is cost per gear. So in this diagram, I have mentioned clearly what is the topland, what is the addendum circle, what is dedendum circle, what is addendum, what is dedendum, what is width of this, then what is the clearance, what is everything I have explained in this diagram, right? Then come to the law of gearing. What is the law of gearing? So law of gearing states that for obtaining a constant velocity ratio at any instant of teeth, the common normal at each point of contact should always pass through a pitch point. So situated in on a line joining the centers of the rotation of the pairs of mating gears. So this is the thing I have mentioned in the diagram. Then methods to avoid interference. You know what is the interference, right? So methods to avoid the interference. So interference means the height of the teeth may be reduced to avoid the interference. Then the pressure angle may be increased. Then the radial flank of the pinion may be cut back, is known as undercutting. Undercutting is also an important term. And finally, the face of the gear tooth may be relieved. So this is called, these are all the methods to avoid the interference, right? And contact ratio. What is the contact ratio? Contact ratio means it is the ratio of the length of the arc of contact to the pitch circle is known as the contact ratio. Contact ratio. So what is the gear materials normally we are using? So generally, we can use two material, right? Two gears, two types of gears, metallic gears and non-metallic gears. So metallic gears means cast iron, then steel and bronze are the materials which we are using to manufacture the gears. And non-metallic means we can have wide materials, right? So rawhide, wood, compressed paper, and synthetic resins like nylon, etc. Right. So these are all the gear material. Right. Come for the gear trains. What is meant by gear trains? Gear trains. So gear train is defined as a combination of wheels by means of which motion is transmitted from one shaft to the another shaft. So it becomes very much necessary when it is required to obtain large speed reduction within a small space. So a gear train may be consists of spur, helical, and spiral. So there are come to the classification of gear trains. So normally it is classified into four types. One is the simple gear train, compound gear train, reverted gear train, and the last one is the epicyclic gear train. So epicyclic gear train. So come to the simple. This is a gear train. Gear train means we have driver gear, idle gear, and driven gear is here. So what is it by simple gear train? What is it by simple gear train? So when there is only one gear on each shaft, it is known as the simple gear train. So the gear one is the driver, and it drives the gear two. So so that is the driver. Gear three is the driven gear, and two is the idle gear. What is the idle gear? Driven gear is otherwise called as follower. Driven gear is otherwise called as follower. What is it by idle gear? So we can call this idle gear as idlers or intermediate gears. So it is the gears which serve to bridge the gap between the first and the last gear. So what is the purpose of this idle gear? What is the purpose of this idle gear? So to connect the gears when a large center distance is required. Then to obtain the desired direction, it may be a clockwise or anti-clockwise of motion of the driven gears. So this is the diagram, right, of simple gear train. So come to the compound gear trains. What is the compound gear trains? So compound gear trains means when there are more than one gear on a shaft, it is called as a compound gear train. So the compound gear train means so this is a compound gear train. So the gear in the compound gear train, the gear one is the driving gear mounted on a shaft A, right? Shaft A, and gear 2 and gear 3 are the compound gears, which is mounted on the shaft B, which is mounted on the shaft B, and the gears 4 and 5 are also a gear compound gear, which is mounted on the shaft C, and the gear 6 is the driven gear. So final output is the driven gear. So input is the driving gear, output is the driving gear, driven gear, and other gears are compound gears. And it is mounted on the shaft B. Then what are the advantages of compound gear train over the simple gear train? So first thing is larger speed ratio can be obtained with smaller gears. Then different types of gears may be used in order to suit the given conditions. So motion can be transmitted in the round bends and corners, right? So come to the next type of gear is reverted gear. Reverted gear. So it is in the diagram, and the reverted gear when the axis of the first gear and the last gear are coaxial. So in the same axis, so the same axis, that is called as an coaxial. And then the gear train is called as a reverted gear train, right? So here the gear 1 drives gear 2 in the opposite direction, since the gears 2 and 3 are mounted on the same shaft, and hence the gear 3 will rotate in the same direction, so that the gear 3 drives the gear 4 in the same direction as that of the gear 1. Thus, in a reverted gear train, the motion of the first gear and the last gear is like same, right? So that is the thing. The main application of this gear train is the automobile gearboxes, then lathe gear back gears, then clocks, then industrial speed reducers, etc. Come to the last part, that is the epicyclic gear train. Epicyclic gear train. So what is the epicyclic gear train? So in epicyclic gear train, when the gears are arranged in such a manner that one or more gears move upon and around another gear. So then the gear train is called as an epicyclic gear train. So this epicyclic gear train, the axis of the gear wheels remain fixed relative to one another. So, but in epicyclic gear train, the axis of the gears while rotating about the axis of other wheels, in addition to the revolution around their respective axis. So, an epicyclic gear train, or sometimes called as planetary gears, are sun and planet gear trains, because of the fact that the gear B goes to round and round the gears. So just like a planet, right? So normally planet is moving around the sun. Here also the planet gear is rotating or revolving the sun gears, right? It is mentioned in the diagram, right? So it is called as an planetary motion, right? So that is called planetary epicyclic gear train, right? And here also we have an application of epicyclic gear train, that is a differential gears of automobiles. So you can see what is the differential. You can see that in auto trucks, buses, right? Like you can see that, right? Then back gears of lathe, then pulley blocks, hoist, then wristwatches, etc. See, types of epicyclic gear train. There are some types of epicyclic gear train. When there is only, so it is normally classified into two types. One is a simple gear epicyclic gear train and compound epicyclic gear train. I already explained you what is the simple and the compound. So when there is only one gear on each shaft in any epicyclic gear train, means then they are called simple epicyclic gear train. And when there are more than one gear on a shaft in any epicyclic gear trains, then they are called the compound epicyclic gear train, right? And sun gear. What is in the sun gear? The gear at the center is called the sun gear, and the gear those whose axis move are called planet gears. So these are all the sun and planet gears, right? So epicyclic gear train has some very wide application in automobile, right? And so these are all that. Then we can have so many problems regarding these type of gears. So we can see those problems in the further videos. Thank you.